I won't be covering very much new material this week. This will be more or less a review of the last video, but it will present the first half of the code for using the functions that are necessary to complete the problem set. And the second half will be the dplyr functions that can also be used, but they don't have to be used. Some of you have inquired about this. There's not one way to answer or to do data work in R. There are many different ways because of the vast amount of libraries that are available. Now, the reason I want you to know dplyr is for those who are looking to use R in the future and study it more, it is one of the most important packages, and I find it is actually easier to use than not using it. But for people who are hoping to just get the basics of R, which is completely fine, I will just show you the necessary commands in the first part. And then for those of you who want to know a little bit more and are interested to know more about dplyr, I will cover that in the second half. But again, more or less, this is a review of what we covered last week, but just hopefully in an easier to understand manner. Now we will just import our dataset as we have done so in the past using the read.csv function, and making sure that that file that we are importing is both correctly named in quotes and exists in our local directory. So we will do that, and it looks like our data imported. And then we will just look at the head function to make sure that's the right data, and lo and behold, that's the same data set that we were using last week. So moving on to 1.1, this is for problem 2C of the problem set. We need to make a plot, a scatter plot, and this is the plot function which we will be using. So we will run this, and as usual, it will show up in the plot section of our bottom right section. Problem 2D will require a correlation function. So we will select our data by putting the name of the data frame and then the specific column that we want to access, as well as another one to compare the correlation. And we will run that, and that seemed to work. So this 0.872 would mean that there's a correlation that's pretty strong between the two variables, which makes sense considering their GDP and wealth. This is, again, these examples are not the examples that answer the questions, but in theory you should be able to just put different columns in, or put different information in here, and you should be able to get your answers. So moving on to problem 2E, we will want to use this filter function. I guess in this case it's not a function, but it's just a way to filter the data frame. A few of you have actually asked me about this, and it's actually quite confusing what we are doing, so I'll try to explain it as clearly as possible. This data set that we have, again, if you want to look at it, you can always just click this little box here, and then we can look at that data frame. Our data frame has all these observations. In this case, it's actually countries. Our observations are countries. Now, we might be interested in countries that are only of a certain regime, which is what the problem set wants us to find. And as a result, we might want to create a separate data frame with only the rows, only the observations, only the countries. So whatever you want to call it, you can call it row, a country, or observation. If you wanted to create a new data frame with only specific rows, then we need to do something called filtering. Now, in this example, it's kind of similar to what we did in the first assignment when we wanted to filter by gender. In this case, we are accessing our data frame, the whole entire data frame this time, and that is actually why this assignment is a little bit different. Is in the first assignment we actually specified the column that we wanted. We only wanted to take one column, But in this instance, this will allow us to take the whole data frame by just having this df here rather than df followed by a column name. And then, as last time, we also had this, again, the same data frame name and a specific column that we wanted to select by. But this is actually, this equals to 1 is selecting by specific rows. So in the case of regime equals to 1, what we're doing is just combing through this data and combing through and only choosing, like, for example, Guinea-Bissau, that's number 1, so we'll take that. Mali, we'll take that. But we're leaving out all of the other ones. So we should have a new data frame that only has those observations. So let's check it out and see if that worked. We go to autocracy. All the other data, of course, was carried over, and the regime looks like there's only of regime 1, so it was successful. So the democracy, so that will be called our autocracy data frame. And then for democracy data frame, we can do the exact same thing. And instead of using the 1, we just set it as 3. Now this comma actually allows you to take all of the different columns, so that's why we have it there, so it's important to still have that there. And again, if we were to run the same data set, but with only the, say we put this regime column on the outside rather than just the data frame, what that would do is create a new, it actually doesn't work. So actually you can't even do that with this method. So bear with me, that this is a bit confusing, but this is the way you create a new data frame based on certain rows. So again, let's go back in to the democracy data frame. Let's take a look at it. And regime is all 3. So if we wanted to do this, we could do it with other ones too. So we can create a wealth data frame. How about we try that? Wealthy df equals df, and this time we're not going to use regime. We're going to use wealth, and we're going to do it, say equals, well, actually, what we'll do is any observation above 1. So we can also use this. We don't just need to do equals to equals. We can actually set it as all observations above or below a certain level. So if we gotta have the comma there, if we try to make a wealthy data frame and we go in, we see that there are no observations with wealth under 2 and 3. So I don't know if that's actually wealthy countries. I think that might be the poor countries, but that's just an example for you to understand how to do data filtering. We'll leave that in there. So now we will go to problem 2E, and we will be, oh, sorry, this is a continuation of what we just did. So now that we have the democracy and autocracy data frames, we can compare any type of column between the two, and it should show us some difference in theory between the two data sets. And this is the first command here is to print 2 histograms side by side. And then, of course, this is graph 1, and this is graph 2. And we use it like we did in the histogram in the first assignment, if you remember. So just the name of the data frame and the name of the column, and then X label, and so on and so forth. And so when we run that, then it shows side by side. Now moving on to 2F, this is a frequency table. So in this case, our first, so it will be a table function as we used in the first problem set. And then the first set of data, this df wealth or whatever it is that you put in there, will correspond to the columns of that frequency table. And the second set of data will correspond to the rows. So when we run this frequency table, we we can see that these columns should be the wealth, and the rows right here should be the regime. So we can actually relabel this just to give you an idea of what it would look like. I'm not going to do all of them, but you can also rename the columns, which is really convenient because then the data just looks a little bit better when you present it. So now, as you can see, that is in there when we run it. So now moving on to problem 2G, it's more or less a continuation of that 2F. It's using that frequency table data that we've saved right here, and that we were just manipulating, and it's just using the prop.table function, which gives us percentages, and so it should be the exact same data, but just put into percentages. So it makes sense if the 0 is 0%, right? Because there's no observations. So that looks good. And then the prop table, more or less the same command with a comma 2, will give you a conditional probability based on the column. So as you can see here, all of the columns should add up to 1. And that means in our example here that if you are in the regime 1 category, there's an 81% chance you are in the wealth 1 category. There's an 18% chance you're in the wealth 2 category, and then this isn't labeled correctly, but there's a 0% chance that you're in the wealth 3 category. And so just going along, just to make it even more clear, this column here is the regime 2 column, and if you are in the regime 2, if you have a regime that is of the second nature, then you have a 23% chance for wealth 1, 71% for wealth 2, and so on and so forth. And so that's how to interpret that table. So that's more or less the commands that you need for problem set 2. If you are not interested in learning any more about dplyr, then feel free to skip the second part of the video, but I wanted to also just go over very quickly what dplyr is in a little bit more depth, and to show you some of the commands that we've been using just to review. So just again, make sure that when you're using an external library, which you often do when you're using R, that you install it first. So that's step 1. And that after you install it, you run that library command with the name of the dataset inside, or sorry, with the name of that library inside, and then you will be able to use it. Now I've already installed it, so I don't need to install it again. And I ran it, and this means that it ran. There was no error. So, and you can double check that by running it a second time, and if it's just blue, then you know it worked. So why use libraries is a question that I got, and the short answer, in my opinion, is that they're often actually a lot easier to understand. So let me just compare 2 sets of functions from our assignment to show you what I mean. So in one of the problems, we use this core function, which is just correlation, and you put in the name of the data frame, you have to type in the $sign followed by the name of the column, and then you take a comma, and it's not, I guess, in my opinion, the prettiest to read, nor is it very intuitive. But when we're using dplyr, we can use the pipe operator, which you can, I think I've mentioned this before, but I'll mention it again. The shortcut for the pipe operator is Command Shift M. Command Shift M. And so that will make it a little bit easier. And then we use the select function, and that will just allow us to select the data, whatever it is that we want, without typing in the name of the data frame again. And then allowing us to put on one more pipe operator and then use the correlation function. And this, for me, is a little bit easier to read because you can see that we are selecting these certain columns, and you can also very clearly see the function that we're using. And this is a very easy example. It usually applies to a little bit more complicated code where it really becomes clear, but I will try to make that more clear as we go along in these dplyr commands. So in dplyr, again, the select function is to select the columns of our data set. And so we've used this in the first problem set. So I just wanted to formally show you that again. The really nice thing about it is that you can also use it to select all columns that contains a certain string. So for example, if I had a huge data set with many different GDP columns, I could just say contains GDP, and then it would show me all of the columns that contain GDP. So this worked, but just let me show you a little bit easier to understand. So I had to add the head function to just make it smaller so we could read the data, but surely enough, it selected the column that contains the words GDP. So it's really convenient if you have a large data set. Now, filtering is also, in my opinion, a little bit easier to use than the other method. And the previous method had us, in order to do the same thing, we had to do df regime equals to 1 comma, and then that was how we filtered the regime ones. But in dplyr, it's I think it's a little bit more intuitive in the sense that you just write down the name of the data frame, and then you write down filter, and then regime equals to 1, and then it will be able to do the exact same thing. Now, in dplyr, you can also, of course, do what we did previously, which is to filter by using inequalities. So in this case, say we want to filter GDP above a certain level, we can also do that. And this head function that I'm attaching here is just for readability, so we can read it, so it's not a long output. But if you just erase this, then you can always save the data set as a new data set by typing in whatever it is that you want to name it and an equal sign, and then that will save that new data that you created. But the head function is just used to make it easier for you to read right now. We can also filter with multiple conditions. So in the first case, this is or, and the second one is and. So in this example, we are filtering all of the rows, all of the countries that are above GDP of 1700 or 17,000, excuse me, and below GDP of 500. So kind of getting the outliers. And the and will be something that this condition has to satisfy both. So if we put an and here, that wouldn't work because there's not countries that are both simultaneously 17,000 and 500. The and is really nice if you're wanting to filter by other columns. And so we want to see all of the GDP countries over 10,000, but with regimes too, and we find that Singapore is the only one. So now we will move on to 2.3. Mutate is, again, something that I showed you earlier, but I didn't properly explain it because I didn't have enough time. But mutate is just a function to make new columns. So in this example that I'm showing now, I'm just manipulating, I'm just adding many different manipulations of GDP. And so you can see that mutate actually retains our original columns, and every time you add a new column name and equal sign and that followed by a column, a function, then you actually are just tacking on or creating a new column in our existing data frame. And again, if we wanted to save this mutated column, df new or whatever it is that we want to call it, and you put that on there, then you could create a new data frame. But remember, you'd also want to get rid of the head because we would want all the observations. And again, this example that I gave was only a manipulation on GDP, but we could also make it a manipulation on, you know, regime or whatever it is that we wanted, standard deviation of regime, and then that would work too. So it's really nice for creating new columns. 2.4 is the summarize function, which I think we have also used. And this just gives summary statistics, and there's many that it can give. In this example, I'm showing mean, median, sum, number of observations, first observation, last observation, variance, standard deviation. Again, I should have explained this better in 2.3, but 2.3 shows the log, the mean, the standard deviation, the percentile, which is actually really quite convenient, and the cumulative sum. And again, down here, there's these functions are used in summarize. So they kind of look similar, but the difference is that mutate creates new columns, whereas summarize just simply gives summary statistics, as you can see here. And then we will take a look at the group by function, which I think I've also previously showed you. This is, I think, pretty straightforward. You, again, access the data frame, you group it by whatever it is that you want to see broken down. So in the case of gender, we wanted to see the gender, the 0 observations of gender, the 1 observations of gender, so male and female. And then we, of course, we don't want to just split them up. We also want to compare them, right? So that way we have to tack on that summarize function, and we can, for example, find the mean, and this should show us the breakdown for all the different regimes. Now, this is why I think dplyr is so helpful, is because you can attach so many functions with relative ease. And in this example, I'm using select, group by, mutate, and summarize all in one. I'll show you what select, group by, and mutate does. So select, I would be selecting only a certain number of columns, and then I would be grouping by whatever column that I wanted. Say I wanted to do a group by, and then I wanted to mutate. I wanted to create a new column. I could do that all in one go, so to speak, and adding on that summarize will also allow us to take a summary of whatever that new column it is that we created. So I'm just kind of going down. So that mutate that we created here, this GDP log, we can actually take the summary statistics in that next function of it. So it's really convenient, and then you can see that that's the output. The last thing I wanted to do is also optional, and it's something that I want to do at the end of these videos, is to introduce you to a library in R that some of you might find helpful or useful or interesting. So I'm also looking for some feedback on this. If you are interested in a certain data set, if you're wondering whether that also has a library, then I'll be happy to take requests for different libraries, to teach you different libraries. But in the meantime, I will just introduce you to a few libraries that I find very cool and helpful for data. And this data set is actually from the World Bank. It's the World Development Indicators that are popularly used in many development economics courses, and really by many, I think, people in public policy working in the developing world. And so this will allow you, by just downloading the library first, you need to install packages, which I've already done. It takes a little bit because this package is, I think, quite large. And you run the library. If you see that there's blue at the bottom, then you know it succeeded. And I just want to introduce you to two functions. If you want to know more about this package, I'm happy to teach you more. If there's no feedback, I'll just introduce another one next week. But for this example, I'm just teaching you two functions. The first function is the search function, so WDI search. And this will just search for any data that you're interested in. So in this example, I'm wanting to search by poverty. This and this right here are not really that important of details. But if you wanted to know more, I can go in depth again in a later video about what exactly everything means. But for this example, I just want to show you what would come out if we use this as a search. So it looks like there is a lot of poverty data. It says there's 365 data sets that have the word poverty in it. And so if we wanted to search by, say, GDP or some other factor, we can also do that. And that shows GDP. But let's go with poverty. And let's do that search once again. But let's actually put that data into... actually, let's not do that. What we're going to do is do the poverty search one more time. We're going to see that... the name of that is on the right-hand side, and that's kind of more of the explanation, and the indicator is the actual World Bank code. So that's what I'm actually referring to here in this field. I'm looking in the name rather than the indicator. And so let's just try to take one of these and download that data in this next example. So this function is the WDI function. And that will actually download the data. So all we do is say write WDI. We have to write this indicator equals, and we will just write down the poverty head count for $202.50 a day. So we put in that indicator here, and then we put in a country name. So in this example, I'm just going to look for Mexican data. So that's MX. And then a start date and an end date, and then I save that in this poverty df file. You don't have to save it. You could just run it, and you would more or less be able to see it, but you wouldn't be able to access that data. So just be aware of that. It's exactly like reading a CSV. You want to save it. And yeah, just like that, we have downloaded data directly from the World Bank website. So again, if you want to know more about libraries like these, please let me know. If it seems too much, I don't have to do these at the end of the video, but I just wanted to add it as like a little bonus to see, or to show you that there are some interesting libraries in R that you might be interested to use.